Hello and welcome back. I'm sure you enjoyed that break with the stretch and had something to eat and get the energy flow coming back. Okay, now let's go and learn how to program from scratch. So, for our convenience, I already opened the IDE. So, we're going to start a new program. I'm going to go File, New Project, File, New STM32 project, and also it will let you to select the target selector, and also I have connected the hardware as you can see with the breadboard. So you need to connect the hardware as well. I'll take this view off now, I'll show you later. So first step, as you know, you need to go to board selector. You need to choose which board you are targeting to. So Nucleo F411RE, choose that board and select this board and hit next. Then give a project name. So we are on day 20. Day 20, I will give it as ADC. And we're starting from scratch, so click empty and then finish. This will start to produce and give the files. So it's already started and it will give all the necessary files that we need to program. So we got to wait. It's on 83% settings. Okay, we are in. So click on the source code. Click on the source and click on the main.c. I will close the rest of the program so you won't get confused. Okay, click main.c. As you know, this is for general reference. You need to tell the file name, what program it is. Usually if you write ADC, then you need to write adc.c and then your name and then a brief message about which part of this program it's going to be, and then a little bit about the license. So anyone who come in, they will know what kind of program that is and they will understand. So I'll go in and delete all the unnecessary or default lines. I'll remove that and we don't need this. So we're going to use the printf statement and we're going to view the output in the data console. For that you got to use another library called stdioh, stdio.h, and then you can just come here and create a printf statement. You go display ADC value and \n. Okay, first step, I'll save and build the project to create the .elf file. We need this, so build the project. Then we'll set up the debug configuration and then I'll go into explaining everything for the ADC program. So it's compiling, it's going to give the .elf file. Just one sec. Okay, so it's generated and it is happy. So now we need to go right click again on the project name, make sure it's the same project you're working, and click debug as, go to debug configurations, choose the .elf file. So we are on day 20. Double click on the STM32 and it will take you to the .elf file on the main day 20 ADC. On the debugger, make sure you click the programmer link, st link, you enable that, and then we're going to view the output today at the ITM data console. So that connected via the serial wire viewer, you have to enable this and apply and then debug. This will change the mode from C++ perspective to debug perspective, so you can start to troubleshoot and look everything in there. Okay, first we will go and enable the clock for the GPA and then enable the APB2, that's where the ADC1 is connected. So I click on switch and we are in debug mode, so we can go window, show view, and we need to collect all the registers. So I'll go to SFRs, and we need the first SFR. You need to enable the GPA OI, so you need to go to RCC register, that's reset and clock control register. You need to go for AHB 1NR. You need to have this register first. You need to enable this. So to do that, I'll start here, u int 32_t, and declare the variables, pointer variables with p, and the register you copy here. Then typecast this u int 32_t, and you got to copy the address as well. So copy that, Control C. Okay, so this is to enable the GPIO port clock. Enable the GPIOA clock, or GPIO port A clock. So copy this. The next step, you need to enable the peripheral bus APB2. So go again here, APB2NR, you need this. Copy this register and replace it here, and copy this address value from here and replace that to here. This is the enable the ADC 1, that is peripheral bus 2 clock. Okay, then we need to set the alternate function, that's the analog function. So for that you need to go to GPIO Mod A. So I'll copy and paste already in there. So oops, I'll copy this and paste it here. So we need GPIO Mod A. So if we go into GPIO A, you need the mod register. So you need this modder. So it is a GPIOA modder register. Modder, and then copy this address. Control C, come here and paste it. So this is to set alternate function as analog mod. Then after that you need ADC register. So copy this and paste it here once. So we're going to use ADC1. So if you scroll to ADC1, you can find the registers. There is ADC. There is the one, ADC1. And we're going to need the status register first. So copy this. So I'll call it as ADC1_status register, and its value is 40120000. So copy the address and replace it here. Control V, and this is ADC1 status register. Next, you need the control register. So you can use, there is 2 control registers available, so we're going to use in our program control register 2, CR2, which is this, and you can copy this and use that ADC1 control register 2. Then you need the sequence, control C, paste it here. You need sequence register, regular sequence register, SQ3. That's a control register, and then you need the SQR3, this regular sequence register 3, SQR3. So the address for this is 20C4, and this is the regular sequence register. Okay, then you need the data register, that's the DR. So control C, control V. You need, after the conversion you need to read the value, so you need to read that from only the data register. So you need to copy this, control C, okay, this is the data register. Okay, now we collected and declared all the variables. Now we're going to go and write the ADC initialization function. So I will create the function prototype here. So ADC1 underscore INIT void. Write the function here, control C, okay, let's see if, let's go and build the project to see for any errors. Build projects, so because you keep on writing, you may miss something. It's always good to be checking every time. Whenever you write some line of code, you always make sure it's error free. Okay, so now we need to enable and set all these bits. So first you need to enable the GPA Mod. So first step, enable the GPA Mod, which is, you just do a bit R and you set that as 1. That is a bit 0 you're using. You can either set directly to 1, or you can use 1U / the unsigned way. So either way you can do it. And then you need to set the PB to ANR. That's the second. My mouse, come on mouse. Copy this. and you need to set this as R with 0 1 0 0, and this is to enable the ADC bit 8. Enable ADC 1 bit 8 to 1. So when you do that, you'll get this value. And then you need to set the alternate function. So you need the GPA modder. Then copy this. The modder is, you need to write the PA1, so you can just directly write a 0 cross C. Shift R 0 cross C. This is to set to analog mode on PA1. Okay, so the next one, you need to clear the or disable the ADC first before setting it up. So you need to set this to 0. Set this to 0, Control C, come here and paste it. You can directly set this to 0, so you're disabling the ADC first. Disable ADC. And then you need to set the sequence. Start the sequence. Set Control C. So you set this to 1. Set the sequence. And then read the data after the conversion happens with the data register. So go here and copy, and you just R with enable 1. So this is your enabling the ADC. Enabling ADC. Okay. So we did the initialization. So you have to call this in the main function. ADC1 underscore I NIT off, and then I'll put a simple while loop to start with. While of 1. So first step, as you know, start the ADC conversion. First, start the ADC conversion. So to do that, you need SW start bit. You got to set that to 1. Set this to 1. So set the control register with that value. Control C. Come here, and I showed you how that 4, how you're writing that 4 here. 3 1 2 3 4. Because the 31st bit, if you set that, that's where SW start is, and you're enabling that, and you will get the hex value in that. Set bit 30 as 1. Then you got to wait, you got to compare with the status register to see the conversion starts, and you got to wait. Conversion, then I'll write a while loop. You have to check for the value. the status, because we are checking whether the conversion started, and you got to wait until the conversion finishes. So you got to AND that with value 2, because he is setting it with port A mod A1. So wait until until ADC conversion completes. So once it's completed, then you need to read the analog value from the data register. So this is the data register. Copy that. Data register. So then you can print the values written there, reading there. So Control V, printf ADC value is in decimal D backslash of n, comma, which value you want to read, the analog value, log value. So that's done, and the while loop ends. Okay, save, and we got to initialize this analog value globally, so it knows to read. So I'll copy this, go here and paste it, and then typecast this value. So u int 16 underscore t analog value. Okay, so now you have to create a small delay. So you need to write a small delay program, which I will write here directly. Void you need to include a delay of so write the delay before the main. Void delay of and just a simple for loop for u int 32 underscore t I equals 0, then I less than some random value 300,000, then increment the value, finish the loop, and then when you come here, put a delay of, call that in the main function, delay of. Okay, so now you have written the program. You just save this program and do a compilation to see for any error. Build the project. Three errors. Unknown type name enable. Oh, sorry. Supposed to be comment. Sorry, my bad. And expected error. Okay. So this should solve this build project. Yeah, it's happy, it's going through. So because we're going to check the output with SWV ITM data console, you need to copy the printf code that you enable right from Day20, go to CIS Call. You need to copy that small piece of few lines of code through the CIS Call and paste it in this program. So you have to go there and copy from line 33 till line 48. Copy this close this, you minimize this so I don't get confused. Open this CIS Call. And then you just scroll down in the CIS Call, you paste it here. Then copy the send ITM send care function name, Control C, come to right, int right, and comment this line, I will put care, and call the function, and then pass the pointer variable, Control C, Control V. Okay, we are set, and just right click, paste. So again, build the project. By this time I will connect the hardware as well. I'll open the hardware view so you can see a bit. Hardware, as you can. So I'll do the VCC connection to the first pin. Okay, I'm using a potentiometer, a pot with the screw type, not the analog round knob, but this is a screw type. You need to adjust that value so you can see the output. So I'll do that by going into debug mode. So right click, debug as STM32 application. Wait for it to complete, and the program is loading. It's loaded. Okay, and go to SWV ITM data console. You got to set this bit as enable bit 0 as 1 to view the output, and then you go and run. Okay, stop and relaunch. I need to click on start trace, and then I'll adjust the value of the pot variable resistor. So switch, then go start trace, and then hit the run button. Now display ADC value, it's showing that value. Now if I go and alter this, you got to adjust this to give the value. Okay, maybe I'm not getting the 5 volts on this resistor, just give me a sec. Just one sec, I need to set this to PA1. I connected to PA0, that's why. PA1. A1, and I'll go and relaunch the program. So as you can see, the three colored cables, the blue is the ground pin, that's the black, and red is the 5-volt cable, and the blue cable is for the center pin to connect to the analog pin, that's PA1 switch. STM data console, start the trace, and then go and run the program, display ADC value. When you start to adjust the knob, okay, just give me a sec, it's not printing this value, just one sec. I think you don't need this print, this is just to put it there earlier to show the printf statement, which or this part may be needing more 5 volts, so maybe either one of that, but I'll quickly check. Go to switch. I don't have the analog knob part to show to you. I have only this digital, or you can call a screw type, where it's not digital, it's a screw type console. So here, start the trace and then go and run got to stop this. I need to check my program again. I'll be back with the Unitic. Printf display ADC value, start the conversion, while of 1, ADC1, you're checking with the SR value, yeah, and waiting for ADC conversion stops, then you bringing that value to analog value. Void of delay, let's go to day 7. Checking the delay program, which we have written earlier, void delay, it's okay, looking okay, while of 1, so you ended this loop, the int is ended analog value. Int main of void, enabling the registers 0, 1, 0, 0, init, you call that analog value. Okay, just give me a sec, I'm going to troubleshoot and I'll come back to you and explain. Maybe I need to go and find a better pot. I'll come back in a short while and I'll explain to you and see the output. So I'll see you shortly.